Hello everyone, and welcome to Lesson 3-2, Proving Angle Relationships. Before you begin, I would like you to go through and remind yourself about how to find the relationship between pairs of angles. So please, in your book now, go through and fill out this page. I will give an answer key on the website. Thank you. In this lesson, we are going to look at what happens when we make those two lines parallel and then cut them by a transversal. Our pairs of angles are going to start resulting in different types of numeric relationships, as well as just this paired relationship that we have a name for. Before we can really begin talking about these, we're going to have to prove some theorems. And these theorems are going to establish relationships within these pairs of angles that will be very useful for us in the future. The theorems we don't cover in the notes, we will do in class. But if you would like the opportunity to get ahead, please feel free to go ahead and try them on your own. There is no online Tier 2 activity for this section because we're going to spend the Tier 2 in class doing proofs. So, the first thing we're going to look at, though, is the corresponding angles postulate. And the corresponding angles postulate says that if I have two parallel lines, K and L, cut by a transversal, then all corresponding angles are congruent. So looking at this diagram, I see that 1 and 5 are corresponding angles. Therefore, angles 1 and 5 would be congruent. So go ahead, take a moment and see if you can fill out this chart right here on your own, and I'll give you the answers in half a second. Please pause. Check your answers against mine. You'll notice that all of the angles that are corresponding have to be congruent to each other because of the corresponding angles postulate. Now again, postulates are statements that we know to be true, but we can't necessarily prove them. We assume them to be true, and we're going to be basing the following proofs on this postulate. Now, if I want to find x's in this diagram that will make these two lines parallel, well, we know that if those angles are congruent, then the lines are parallel because of the corresponding angles postulate. So I am going to set those two angles equal to each other for this problem to find x. So we're going to do that. I am going to set 5x minus 10 equal to 2x plus 2, and we're going to solve. So I'm going to subtract the 2x over, and then I'm going to add the 10 to the other side, and I end up with x equals 4 as my answer. So because corresponding angles should be congruent when lines are parallel, I was able to set them equal to each other and solve for the variable. So similar problem, if measure of angle 1 is 4x and measure of angle 6 is 11x plus 30, find the measurements of each angle in the diagram below. I would like you all to try this one on your own, pause the video, and then I will give you the answers here in a second or two inside the video. Now this problem isn't quite as straightforward as the previous problem, because if you look, angle 1 and angle 6 are not corresponding angles. So I'm going to have to do a little bit of thinking to figure out how they might be related. Now, I know that angle 1 and angle 4 are congruent because they're vertical angles, and vertical angles are congruent. And angle 4 and angle 7 are corresponding angles. So angle 4 must be congruent to angle 7. And if you look, angle 7 and angle 6, they form a straight line together, so they must be a linear pair. Therefore, the measure of angle 6 plus the measure of angle 7 must be 180 degrees. And because angle 7 has the same measurement as angle 1 by the transitive property, as we know from proofs, we can plug in 4x for angle 7 and 11x plus 30 for angle 6. And when I solve this equation, I get that x equals 10. Now again, measure of angle 1 is 4 times x, so 1 would be 40. And measure of angle 6 is 11x plus 30, so 6 would be 140. Take a moment and complete the measurements for the remaining angles in this problem. Did you notice how all of the obtuse angles and have the same measure, and all of the acute angles have the same measure in this diagram? All right, now we are going to move on to our first proof in this section. The first thing we're going to prove is the alternate interior angles theorem. And the alternate interior angles theorem states that if two parallel lines are cut by a transversal, then alternate interior angles are congruent. So I have my sketch right here. I've given you the same sketch as we've had in the previous problems. And I need to figure out what my givens and my prove is going to be. So if two lines are cut by a transversal, so two parallel lines, that is definitely going to be my given, that we have two parallel lines. And my proof will be alternate interior angles are congruent. So let's take a moment to fill that in on this chart. So I need the fact that K is parallel to L, and I need to pick a pair of alternate interior angles to prove to be congruent. I am liking angles 4 and 5 this morning personally, but you could choose either 4 and 5 or 3 and 6. What I'm going to do, prove angle 4 is congruent to angle 5. And now we're ready to start our proof. We have statement and reason. And of course, our first given is always, or our first line is always the given. K is parallel to L, given. Now, I really only know one tool right now to help me with this proof. I know the corresponding angles postulate. And if I'm trying to prove 4 congruent to 5, I am going to need some help. Well, looking at this, I see that 4 and 7 are corresponding angles, so therefore they must be congruent. And then I see that 7 and 5 are vertical angles, so they're congruent. So I think that's the path I'm going to take. I'm going to say angle 4 is congruent to angle 7 by the corresponding angles postulate. Then I'm going to say that angle 7 is congruent to angle 5 by the vertical angles theorem. And now I have this lovely cascading effect. So I can get that 4 is congruent to 5, angle 5, because if 4 is congruent to 7 and 7 is congruent to 5, then 4 is congruent to 5 by the transitive property. And that would be property of congruence, because we're dealing with congruent symbols. Well, I have now proved what I wanted to prove, so I can finish my proof. QED. So you are going to be going through and proving relationships for all of those wonderful vocabulary words we learned in the last lesson. But there's a flip side to this. We actually have the converse of all of those same theorems. For example, the converse of the corresponding angles postulate states that if a pair of corresponding angles formed by two lines cut by a transversal is congruent, then the two lines will be parallel. If you recall from earlier, oh, there it is. That's the flipped version of this if-then statement. So here we were given two parallel lines, and then we were told that the corresponding angles are congruent. Whereas in this one, we're given corresponding angles are congruent, and we're proving that they're parallel. That goes back to the conditional statements and their converses that we learned about in Unit 2. So looking at this, what statements would we write to make K parallel to L based on the corresponding angles postulate? Take a moment and write down your answer before continuing the video. Check your answers against mine. If we are able to prove that, if we are given that any of the corresponding angles are congruent, then those two lines are parallel. All right, let's take a look at a full-blown proof for using a converse. So if two lines and a transversal form congruent alternate interior angles, then the two lines are parallel. So we have our sketch, but we have different givens this time. Here I have that we're going to start off with congruent alternate interior angles. And we are going to prove that two lines are parallel. So, looking at my diagram, I'm going to pick my favorite pair of congruent alternate interior angles. I'm going to choose 4 and 5, and I'm going to write my given statements and the proof statement to match the diagram. So, I am given that angle 4 is congruent to angle 5, and I want to prove that the lines are parallel. Prove K is parallel to L. Now, this process is going to be really similar to the last proof we just did. We're just moving in reverse. So looking at what I'm given in this diagram, we know 4 is congruent to 5, and we know that 5 would be congruent to 7 because they're vertical angles. Then we'd have a pair of corresponding angles, right, that would help us prove these two lines to be parallel. Because currently the only tool I have is the corresponding, or the converse of the corresponding angles postulate to prove lines to be parallel. So I'm going to start my proof. Statement reason, as always. And we start with the givens. Angle 5 is congruent, angle 4 is congruent to angle 5. Because they're given. And then I can say that angle 5 is congruent to angle 7 by the vertical angles theorem. And now we've got, if 4 is congruent to 5 and 5 is congruent to 7, then angle 4 is congruent to angle 7 by the transitive property. Well, now I've got a pair of corresponding angles that are congruent, which means that I can actually now prove that K is parallel to L because the converse of the corresponding angles postulate allows us to do so. So because we have a pair of congruent corresponding angles, the lines must be parallel. And I am done with my proof. So satisfying. All right. For your Tier 1, I want you to try this proof. I will include an answer key at the very end of this video, but please try it on your own first. And I'll talk to you all in class. Thank you. Bye. Here are the answers to the first page of exercises. Here's the solution to the first proof we asked you to do from scratch by yourself. Thank you.